video I am going to discuss about molecular orbital theory of benzene molecule. So before going to discuss what is the molecular orbital energy diagram of the benzene molecule, first of all we have to discuss why molecular orbital theory for benzene molecule. That is, why molecular orbital theory came into picture for the benzene molecule. The molecular orbital theory came into picture for the benzene molecule in order to explain its stability. We all know that the benzene is highly stable molecule, right? And this is one of the theory which clearly gives the information or predicts the high stability of the benzene molecule. Now we know the structure of the benzene molecule. We are all familiar with the structure of the benzene molecule, right? Now the benzene molecule contains 6 carbon atoms. The benzene molecule contains 6 carbon atoms. Now let us label the carbon atoms. 1, 2, 3, 4, 5 and 6. Now this particular benzene molecule is the conjugated molecule. So already I have discussed about the conjugated structure of the 1,3-butadiene in the previous videos. So anyhow I am going to throw some light on the conjugation present in the benzene molecule also now. So conjugated molecule means the molecule containing the alternate double bonds. The molecule containing the alternate double bonds is called as the conjugated molecule, or the molecule in which conjugated double bonds are present. Those molecules are referred as conjugated molecules. Now the benzene contains the conjugated double bonds. What do you mean by conjugated double bonds? If the two double bonds are separated by the single bond, then those bonds are called as conjugated double bonds. Now let us try to focus on the conjugated double bonds present in the benzene molecule. Now see, in the benzene molecule, the two double bonds are separated by the single double bond. The two double bonds are separated by the single double bond. And these two double bonds are separated by the single double bond. Now since these double bonds are separated by the single double bond, that is, these two double bonds are separated by the single bonds, this molecule contains the conjugated double bonds. Since this molecule contains the conjugated double bonds, it is the conjugated molecule. It is the conjugated molecule. Now, we have numbered the carbon atoms, right? We have numbered the carbon atoms. So according to the numbering, we can say that 6 carbon atoms are present in it. 6 carbon atoms are present in it. 6 carbon atoms means 6 atomic orbitals are present in it. 6 atomic orbitals are present in it. Now how many pi electrons? Already I have discussed in the previous video that when we are talking about the conjugated molecules, we have to focus only on the pi electrons rather than the sigma electrons. What is the reason? I have clearly explained in the previous video. If you want that particular information, you can watch the previous video. Right. Now coming to this molecule. Now this molecule, benzene molecule, contains 3 double bonds. 3 double bonds, and each and every double bond contributes 2 pi electrons. Since it comprises 3 double bonds, so totally in the benzene molecule there will be 6 pi electrons. There will be 6 pi electrons, and these 6 pi electrons of the benzene molecule will be in the 6 p atomic orbitals of each and every carbon atom of the benzene molecule. Now when we are talking about 6 pi electrons, definitely we can say that this benzene molecule contains 6 p electrons. It contains 6 p electrons. So in order to rewind it. The benzene molecule is the conjugated molecule, and since it contains 3 double bonds, we can say that 6 pi electrons are a part of it. 6 pi electrons, and these 6 pi electrons will be in the p atomic orbital of each and every carbon atom. That is the reason we can say that the benzene molecule contains 6 p electrons. So with this concept, we are going to discuss about molecular orbital energy diagram of benzene. Right. Now, before going to discuss the molecular orbital energy diagram of the benzene molecule, let us try to focus. What is the relation? Let us try to recapitulate what is the relationship between number of nodes present in the molecular orbital and its energy. So in the previous class, I have clearly explained that the node is directly proportional to energy and inversely proportional to stability. So if you want this information about why the node is directly proportional to energy and inversely proportional to stability, you have to watch my previous video. Right? If it is not clear, then I will make another video especially emphasizing on the relationship between the number of nodes present in the molecular orbital and its energy, and as the energy is inversely proportional to stability, we can say that number of nodes present in the molecular orbital is inversely proportional to stability. So overall we can say that node is directly proportional to energy and inversely proportional to stability. Now, as a node is directly proportional to energy, what is that molecular orbital which occupies the lowest energy level? The molecular orbital which contains no node. That is, whatever the molecular orbital do not contain any node, that particular molecular orbital will be placed at the bottom most of the molecular orbital energy diagram. That is, it occupies the lowest energy level because node is directly proportional to energy. And as we move up, as we raise up, what will happen to the energy of the molecular orbitals? The energy will increase. And as number of nodes is directly proportional to energy, as we move up, for the first, the lowest molecular orbital, number of node will be 0. As we move up, as the node is directly proportional to energy, number of node will increase to 1. As we move further, number of node increase to 2. As we move further, it increases to 3. 3 nodes are the maximum nodes which are possible for the benzene molecule. So based upon this concept, based upon this stuff which I have discussed with you, the relationship between the number of nodes present in the molecular orbital and the energy level of the molecular orbital, let us discuss about molecular orbital energy diagram of the benzene